Here we have the problem for IPE from Demoivre's theorem. If x is equal to 6 theta, then find the value of x power 6 plus 1 by x power 6. Okay, all of you, these are the problems for IPE. So x is equal to given 6 theta. 6 theta is equal to what? Cos theta plus I sin theta. Okay, all of you. Here 1 by x is equal to 1 by x is equal to 1 by cos theta plus I sin theta. This can be written as cos theta minus I sin theta. X value, x is equal to 6 theta means cos theta plus I sin theta. 1 by x is equal to 1 by cos theta plus I sin theta is equal to cos theta minus I sin theta. X power 6 is equal to here cos theta plus I sin theta whole power 6. This is cos 6 theta by Demoivre's theorem. Cos 6 theta plus I sin 6 theta. 1 by x power 6 is equal to, this is cos theta minus I sin theta whole power 6 is equal to, this is cos 6 theta minus I sin 6 theta. So x power 6 plus 1 by x power 6 is equal to, this is cos 6 theta plus I sin 6 theta plus cos 6 theta minus I sin 6 theta. Minus I sin 6 theta plus I sin 6 theta cancel. 2 into cos 6 theta is the answer. X power 6 plus 1 by x power 6 is equal to 2 cos 6 theta. Okay, all of you? That's all. Here one more problem from Demoivre's theorem for IPE. If A comma B comma C are angles of triangle ABC such that x is equal to cis A, y is equal to cis B, z is equal to cis C, then find the value of x, y, z. Okay, all of you, here you see given x is equal to cis A, y is equal to cis B, z is equal to cis C. A comma B comma C are angles of triangle ABC. So A plus B plus C is equal to 180 degrees. So we have to find x, y, z. X, y, z is equal to, this is cis A into cis B into cis C is equal to, this can be written as cis of A plus B plus C. Okay, all of you. So x, y, z is equal to, this can be cos of A plus B plus C plus I sin of A plus B plus C. This implies what is this? Cos 180 degrees plus I sin 180 degrees. So x, y, z is equal to cos 180 degrees is equal to minus 1 plus I into sin 180 degrees is equal to 0. So this value is minus 1 or minus 1 plus I into 0. This is minus 1 is the answer. X, y, z is equal to what? Minus 1 is the answer. Okay, all of you. That's all. Thank you. We have the problem from Demoivre's theorem. If the cube roots of unity are 1 omega square, then find the roots of the equation x minus 1 whole cube plus 8 equal to 0. Okay, all of you. Here we have given 1 comma omega square are roots of cube roots of unity. Cube roots of unity. Okay, all of you. Here given equation x minus 1 whole cube plus 8 equal to 0 implies x minus 1 whole cube equal to minus 8. This is implies x minus 1 whole cube is equal to minus 2 whole cube. This is implies x minus 1 is equal to minus 2 whole cube whole power 1 by 3. X minus 1 is the cube root of minus 8. These roots are, and then you write x minus 1 is equal to minus 2 omega minus 2 omega square. Why? Because x minus 1 is the cube root of minus 2 or minus 8. Then minus 2 omega minus 2 omega square we can written as. So what is x? X is equal to minus 2 plus 1 and 1 minus 2 omega. 1 minus 2 omega square. Therefore x is equal to minus 1 comma 1 minus 2 omega comma 1 minus 2 omega square are the x values, roots of the equation x minus 1 whole cube plus 8 equal to 0. Okay, all of you, that's all. Thank you. Here we have the one more problem from Demoivre's theorem. Third question, second problem. Find the cube root of 8. You see, all of you, here cube root of unity is equal to 1 comma omega square. So cube root of 8 is equal to 8 power 1 by 3. So 2 cube whole power 1 by 3. So the cube root of 2 cube whole power 1 by 3 are 2 comma 2 omega 2 omega square. Okay, all of you, these are the cube root of 8. 2 comma 2 omega 2 omega square. Why? Because here you see 1 omega square is equal to omega cube is equal to 1. Here also 2 omega square is equal to, this is 8 into omega cube. Omega cube is equal to 1, 8. Okay, all of you, by using this formula, so here 2 comma 2 omega 2 omega square are the cube roots of 8. Okay, all of you, that's all. Here we have question number 4. Find the values of the following. First one, 1 plus I root 3 whole cube. Second one, 1 plus I whole power 16. Third one, root 3 by 2 plus I by 2 whole power 5 minus root 3 by 2 minus I by 2 whole power 5. So, first one, you see 1 plus I root 3 whole power 3. Okay, all of you, this can be written as 2 into 1 by 2 plus I into root 3 by 2 whole power cube. So, here this is, what is cos theta? Cos theta is equal to 1 by 2. Cos how many degrees? Cos 60 degrees, 5 by 3. So, sin theta is equal to root 3 by 2. This is sin 60 degrees. Okay, all of you. Then you can write this as implies 2 cube 8 as common. This is cos 5 by 3 plus I sin 5 by 3 whole cube. So by using Demoivre's theorem, by using Demoivre's theorem, this is implies 8 into cos 3 into pi by 3 plus I sin 3 into pi by 3. This one cancel. 8 into cos pi plus I sin pi. Sin pi is equal to what? 0. 8 into cos pi minus 1 plus this one. this one. Okay, this is I into 0 is equal to minus 8 is the value of I plus I root 1 plus I root 3 whole cube value. What is the value? Minus 8. Okay, all of you, that is the value of 1 plus I root 3 whole cube. Here, second problem 1 plus I whole power 16. Here, second problem 1 plus I whole power 16. So this can be written as, root 2 into 1 by root 2 plus I by root 2 whole power 16. Okay, all of you, this is root 2 power 16. 2 power 1 by 2 whole power 16 of, what is 1 by root 2? Cos theta is equal to 1 by root 2 is equal to cos pi by 4. Sin theta is equal to 1 by root 2 is equal to sin pi by 4. So this can be written as cos pi by 4 plus I into sin pi by 4 whole power 16. Here 2 8 ja. 2 8 ja. Then what we can written as 2 power 8 of. By using Demoivre's theorem, this is cos 16 into pi by 4 plus I into sin 16 into pi by 4. 4 4 ja, 4 4 ja. So this is 2 power 8 into cos 4 pi plus I into sin 4 pi. What is cos 4 pi? This is, you see here, this is the one complete rotation is 2 pi and 2 complete rotation is 4 pi. So this is nothing but cos 0. Cos 0 is equal to 1. So 2 power 8 into this is 1 plus I into sin 4 pi is 0. 0. So this is 2 power 8 into 1. 2 power 8, this is 2 power 8. 2 power 4 is equal to 16. 16 into 16, 256. This is equal to 256 is the value of 1 plus I whole power 16. Okay, all of you. That's all. Thank you. Third problem. Here, third problem, you see all of you. Third problem. What is third problem? Root 3 by 2 plus I by 2 whole power 5 minus root 3 by 2 minus I by 2 whole power 5. So what is root 3 by 2? Cos theta is equal to root 3 by 2 is equal to cos 30 degrees. 30 degrees is pi by 6. Sin theta is equal to 1 by 2 is equal to sin 30 degrees sin pi by 6. Then we have to write this as, this is cos pi by 6 plus this is I into sin pi by 6 whole power 5 minus cos pi by 6 minus I into sin pi by 6 whole power 5. By using Demoivre's theorem, cos 5 pi by 6 plus I into sin 5 pi by 6, this is minus, and this is minus cos 5 pi by 6 minus I sin 5 pi by 6. Okay, all of you. Then what we can written as cos 5 pi by 6, 5 pi by 6 plus I sin 5 pi by 6 minus cos 5 pi by 6 minus into minus plus I sin 5 pi by 6. Okay, all of you. Here minus cos 5 pi by 6 plus cos 5 pi by 6 cancel. Then what is the remaining? 2i into sin 5 pi by 6. 2i into sin pi minus pi by 6 is equal to 2i into Sin pi minus theta. Sin pi minus theta is equal to sin theta. We know that. By using this formula here, this is sin pi by 6, 2I into, this is 1 by 2. Sin 30 degrees value, 1 by 2. This is equal to, I is the answer. Iota. Iota is the answer. Okay, all of you. That's all. Thank you. Here we have one more problem from Demoivre's theorem. Find all values of root 3 plus I whole power 1 by 4. Second one minus 1 whole power 1 by 6. Third one minus 32 whole power 1 by 5. You take first problem. This is root 3 plus I whole power 1 by 4. So this is, you can multiply and divide with 2. Divide with 2 whole power 1 by 4. Okay, all of you. This is 2 power 1 by 4 as common. Root 3 by 2 plus I into 1 by 2 whole power 1 by 2. This is cos theta is equal to root 3 by 2. Cos theta, how many degrees? Root 3 by 2, cos 30 degrees. This is pi by 6. And sin theta is equal to 1 by 2 equal to sin 30 degrees value. This is pi by 6. Okay, all of you. This can be written as 2 power 1 by 4 into cos pi by 6 plus I into sin pi by 6 whole power 1 by 4. 2 power 1 by 4 into 6 pi by 6 whole power 1 by 4. Okay, 2 power 1 by 4 into, so this can be written as 6 of total values 2k pi plus pi by 6 by 4. Okay, where k is equal to 0, 1, 2, 3. So 2 power 1 by 4, 6 of, this is pi by 6. So 6 into 2. 6 into 2. This is, what is 12k pi plus pi by 6 4 ja 24, where k is equal to 0, 1, 2, 3. So 2 power 1 by 4, 6 of, this is 12k plus 1 by 24 of pi, where k is equal to 0, 1, 2, 3 are the values of, this is root 3 plus I whole power 1 by 4. Okay, all of you. That's all. Thank you. Now we go for second problem, minus I whole power 1 by 6. So minus I whole power 1 by 6. Second problem, minus I whole power 1 by 6. Okay, all of you. This can be written as 0 plus minus 1 into I whole power 1 by 6. So this can be written as cos of minus pi by 2 plus I into sin of minus pi by 2 whole power 1 by 6. Okay, all of you. This is 6 minus pi by 2 whole power 1 by 6. Okay, so this is 6 of, this is 2k pi minus pi by 2 by 6 by 6. 2k pi minus pi by 2 by 6, where k is equal to 0, 1, 2, 3, 4, 5 up to 5. There are 6 values. So this can be written as, this is implies, this can be written as 6 of, so they take LCM. This is 4k pi minus 1 by 2 6 12, where k is equal to 0, 1, 2, 3, 4, 5. Okay, all of you. And this is pi. Okay, this is 4k minus 1 by 12 into pi, k is equal to 0, 1, 2, 3, 4, 5 are the values of the minus I whole power 1 by 6. Okay, all of you? That's all. One more problem. Third one. Minus 32 whole power 1 by 5. You see here, this can be written as third problem. This is minus 32 whole power 1 by 5. So, this is 32 whole power 1 by 5 of minus 1 whole power 1 by 5. So, 32 whole power 1 by 5 minus 1 cos pi plus I sin pi. Okay, all of you. Cos pi plus I sin pi whole power 1 by 5. Cos pi value minus 1 plus sin to sin pi value 0. So, this is minus 1. So, 2 power 5 whole power 1 by 5 into 6 of 5 whole power 1 by 5. 5 cancel, 2 into here the values are 6 of 2k pi plus pi by 5 where k is equal to 0, 1, 2, 3, 4 are the values. Then total values are 2 into 6. This is 2k plus 1. 2k plus 1 by 5 into pi where k is equal to 0, 1, 2, 3, 4 are the values of minus 32 whole power 1 by 5. Okay, all of you, that's all. Here we have one more problem from Demoivre's theorem. What is the problem here? 1 omega square are the cube roots of unity. Then prove that first one 1 by 2 plus omega plus 1 by 2 plus 2 omega is equal to 1 by 1 plus omega. Second one 2 minus omega, 2 minus omega square, 2 minus omega power 10, 2 minus omega power 11 is equal to 49. First you take, we know that 1 comma omega square are the cube roots of unity. 1 omega square are cube roots of unity. Means what? Omega cube is equal to 1 condition, 1 plus omega square is equal to 0. So, these are the two conditions applied. So, you take this first one LHS. LHS 1 by 2 plus omega plus 1 by 1 plus 2 omega. So, you take LCM 2 plus omega into 1 plus 2 omega. What is the numerator? 1 plus 2 omega plus 2 plus omega. So, here 3 plus 3 omega by denominator 2 plus 2 into 2 4 omega plus 2 omega square. So, here you see 3 common 1 plus omega from numerator, 2 plus 2 omega plus 2 omega square. 2 as common, 1 plus omega square plus 2 omega. Here 5 omega is there, 2 omega is there, remaining 3 omega. Okay, all of you. But we know that 1 plus omega square is equal to 0. 3 of 1 plus omega by 2 of 0 plus 3 omega is equal to 3 of 1 plus omega by 3 omega. This one cancel. But 1 plus omega is equal to what? 1 plus omega is equal to minus omega square. Minus omega square by omega. Omega cancel. Minus omega. This is the LHS. Minus omega is the LHS. Then you take RHS. What is RHS here? Here this is the RHS. You take RHS. 1 by 1 plus omega. But what is 1? 1 is equal to omega cube by 1 plus omega is equal to omega cube by what is 1 plus omega? Minus omega square. Omega square cancel. Minus omega. This is the RHS. This is the RHS. This is the LHS. Therefore, RHS is equal to LHS. Then what we can written as 1 by 2 plus omega plus 1 by 1 plus 2 omega is equal to 1 by 1 plus omega. Hence proved. Hence proved. Okay, all of you. That's all. Thank you. Here you see second problem. What is the second problem? 2 minus omega, 2 minus omega square, 2 minus omega power 10, 2 minus omega power 11 is equal to 49. Here second problem LHS. So 2 minus omega, 2 minus omega square, 2 minus omega power 10, 2 minus omega power 11. So this is 2 minus omega into 2 minus omega square into 2 minus omega cube whole power 3 into omega. This can be written as omega power 10 can be written as omega power 9 into omega. Omega power 9 omega cube whole power cube into omega. This is 2 minus omega cube whole cube into omega square. Okay, all of you. But what is omega cube is equal to 1? We know that. That is 2 minus omega into 2 minus omega square into 2 minus 1 power cube 1. This is 2 minus omega, 2 minus omega square. Omega cube is equal to 1, 1 cube is equal to 1. So this is omega. 2 minus omega, 2 minus omega. 2 minus omega square, 2 minus omega square. 2 minus omega whole square into 2 minus omega square whole square. Then we have to multiply this one. This is implies 2 minus omega into 2 minus omega square whole square. So 2 to the 4 minus 2 omega square minus 2 omega plus omega cube whole square. Okay, all of you. So this is 4 minus 2 of omega square plus omega 2 common plus omega cube whole square. This is 4 minus 2 of. Here 1 plus omega 1 plus omega square equal to 0 implies omega square plus omega is equal to minus 1. This is minus 1 plus 1 cube. This is 1. Omega cube is equal to 1. We know that. So whole square. This is 4 minus into minus plus 2 plus 1 whole square. 4 plus 2, 6 plus 1, 7. 7 square is equal to 49 is the answer. This is the RHS. Hence proved. Hence proved. Okay, all of you. This is the 49. So 49 is the answer. Okay, all of you. Thank you.